Okay, so let's get started. And last time, I'll move this attendance list away. And last time we have stopped it here when we discussed the basic of ER diagram, and we learned the notation. And there are a couple of kind of key points. Let me refresh your memory. First of all, that entity is represented by this rectangle with the shadow. So the shadow has a meaning of multiple instant. And we learned that we have every entity have to have attributes, and entity can be related to each other by different kind of relationship. And relationship is represent, and this is the notation we're going to be adopting. It's called the Crowfoot notation. So the part B is the standard notation we're going to be using starting from this point forward. Right? And one of the interesting points before I move to the next slide is actually the next few slides will explain uh, what it means. And one of the interesting thing is if you look at the notation from A to B, right, and there are changes. One of the major changes that the line from A is a solid straight line. There's a diamond or an end to end or many to many in between. But you see that when we move to the Crowfoot notation, it become a dashed line, right? So that I hope that you notice that nice small differences. And computer science or information system is a field of representation. If you think about this, all these computer language and everything we write and build in computer information system world is actually built upon a lot of representation. So programming language is a representation. The model or the ER diagram we're building here is also another representation. So everything that in the virtual world is actually you try to use some digital notation to represent one thing, maybe a real thing, maybe an imaginary thing. So that understanding the detail of the representation is important. One of the biggest example, I mean the best example, I mean I like that example myself to share with my student is if you watch the movie Matrix, the first episode of the Matrix movie, there was a thing that when Keanu Reeves entering this building, they're supposed to be kind of rescuing people or something, and he saw a cat walking by and showing up twice, and that's actually a glitch in the computer program or deja vu in the computer program, and that small changes in the computer world is actually a big changes in the everything, the performance representation and the reality that you're going to. So that's here. A lot of these notation we are putting here when you are entering this more sophisticated graduate level world of. It's also true that when you enter in your management world, and don't think that when you are entering the management level, you don't need to worry about this technical, very confusing concept anymore. Just the contrary, you will be facing more detail-oriented, word by word type of examination, right? So go back to the notation we're looking at here. So the difference is one is a straight line, the other is a dashed line, right? So the way I'm approaching this from my logic, the way I look at this is, if you think about if I want to draw a line on a diagram to connect two concepts, two things, which one is a stronger connection, right? Meaning that when you draw a line they are not more difficult to you need to force them to separate, and which one is kind of like a weaker uh, connection, right? So going back to the previous slide, just try to emphasize my point. So the one with the straight line seems to tie the two entities stronger together, right? So the bonding is stronger. If you have a dashed line, that bonding is weaker. Make sense? All right. So keep those two concepts in mind. So dashed line represent a loose. In the terminology of information system design, we call them loosely coupled. So they're linked, they're related to each other, but they're loose. The relationship is loose. Right. Yeah. if they are linking to each other stronger, then that relationship is strong. Right? So if you think about the concepts as friends, the bonding, the coupling between friends compared to family, the friends bonding is what loose. The family bonding is tight. So one is loose, the other is tight. So one is a tight coupling, the other is loose coupling, right? So I'm using a very commonly used language that we use to describe the notation there, right? So that is something that keep in mind and pay the attention to pay the attention to detail on that particular part. So that leads to the discussion that one of probably the most important discussion of this recording here, that is that in entity relationship diagram discussion, a more advanced level discussion, which is what we're doing now. There is a concept called strong entity, weak entity concept. Some entity are strong and the other entity are weak. Strong entity are usually defined as the entity can stand by itself without the existence of other entity. So if you use a human experience, you will say child or child will be relatively weak because the child have to have their parents take them everywhere, and they cannot drive, so at least they are not allowed to drive. So the parents child bonding will be very important. So that will be a tight bonding. So and the weak entity require strong and tight bonding. Right? Now does that make sense? So the child need a strong connection to the parent to exist. So if you look at child and parent relationship, you want to draw a line. So if you draw a line, if you draw ER diagram says, I have a parent and I have a child concept. When you draw a line between them, you want to draw a solid line because the bonding need to be strong. But if you draw a line between like employee and manager employee, then compared to the parents and child, manager employee will be not as strong. So the line between them will be dashed, right? That makes sense, right? So that leads to a conclusion. Notation wise, when we're building the model, when you see a solid line, and every time you see a solid line on one end of the solid line, there's always a weak entity. So solid line always is used to relate to one strong, at least one strong, and the other will be weak. So there will always be a weak entity in the relationship. Right? So that's the thing. So we'll look at the notation in the next few slides. But here it's in the implementation of the strong weak relationship, or so-called tight and loosely coupled relationship. We have a special type of relationship called the ID dependent or non-ID dependent relationship. ID refers to key in this particular case. So when we say ID dependent, it's actually key dependent, meaning that one foreign key is required in one entity or the other. Right? So in this case, we have the example of apartment and building, or painting and print. And the painting and print is based on our textbook example about this little gallery store. So they're selling this duplicate, this print from the actual painting from the artist. So you go to see a Mona Lisa from Louvre. So you can buy this print. So the print is the multiple copy of the painting. So that's what it means. So the print cannot exist unless there is an original artwork. If there is no original artwork, how do you create print, right? So there must be a Mona Lisa painting in the Louvre museum before you can actually print out all these printing that you can sell to your tourists. So that's the thing there. So that it says a dot solid and dash line on the slide, how they are representing here. We take a look at the example here, so we can see that so all three of them are have this concept called a strong entity and weak entity relationship, and they are all represented by this strong bonding or solid line ID dependent relationship. And the particular name that we are describing the solid line is called the identifiable relationship, right? So it's identifiable relationship. When we have a session showing you how to use Microsoft Visio, some of the function or feature from the diagramming tool will become making sense because you need to specify something called identifying or non-identifying relationship, multiple, minimal, maximum relationship. All these will become part of your language when you are looking at the diagram. Right? So these are examples of strong entity and weak entity. And your textbook of use color coding to represent the difference. So the light green or so kind of like a third green color represent a strong entity. The yellow orange color or the orange color entities are weak, right? And so on the top, building, painting, patient are strong entity. Apartment, prints, and exam are weak entity. And again, weak entity cannot exist unless the strong entity exists. Right? So that's the basic concept here. And it is rather important to understand this. The weak and strong entity relationship translate back into our discussion of normalization. They have some connection there, and the normalization usually build a strong or weak entity. Every time you normalize, create a normal form, you build a weak entity, a weak table in the relationship. So. And by the way, the result of most of the normalization exercise is that your design become the number of the table after normalization usually increase. So a lot of time when you look at typical, say for example, if you go into the University of Arkansas, they have a lot of sample data set, including the Sam's Club data set. You look at their entire Sam's Club membership data set, they have like 20 different tables and related to each other. And that is a result of normalization. And some of the table does not make a lot of sense if you are not trained in database world, right? But once you're trained, then you can easily see how do you merge all these back into the original concept and the data concept that you can put together. All right. So there's some.
I have a question. Yeah.
Sure, go ahead.
Can you please go back to one or two slides where you have a solid line and dotted line between employee and
This one?
this one. So between employee and skill, it shows this solid line.
Mm-hmm.
So solid line is always means that there is a stronger bond or relationship.
That's
Or
correct.
when it is a dotted line, there is a weak relationship. Or when you are on this slide, say on orange one and green one,
Right.
in order to show relationship between a weak or stronger, does a line need to be drawn in order to show that there is a
Yes.
stronger relationship exists?
Usually the line is more important than the color because a lot of time we just use a black and white print or paper to draw the model, and especially in the typical project environment. Not all the documents are color coded, so yeah, so line is actually more important. I was trying to uh, look for your question by asking me. This is actually one of the points I'm going to be getting in today's lecture as well. Is if you look at this particular slide, these are the two. They are almost the same relationship, right? One is employee skill, the other is also employee skill. And of course, in this particular slide, that we just try to explain the difference in notation. But the point I want to make here is that the so-called strong or weak relationship, or strong and weak, sometimes are in a gray area. So when the relationship, they can be ID dependent or non-ID dependent, identifying or non-identifying. Uh, some cases are more like a slam dunk case, like building and apartment. That would be, you don't have building, you cannot have apartment. But sometimes, like in this case, employee and skill, will be a little bit ambiguous. You can say that in our database, if there's no employee, then that particular skill disappear, right? That makes sense. If I want to have a special type of skill in our staff, I say, well, I want a virus biotechnicians on our staff. So if I don't have a biotechnician, I don't have that skill. So you can say that the skill can be weak because that special skill is attached to an employee. But you can also say that, yeah, I can create a skill database. I need this particular skill, but this skill currently has vacancy on our human resource list. So you can create that vacancy. If you do not have a skill, you cannot create the vacancy. Then in this case, skill become a strong entity. And how do you make decision? It really depends on the business situation you are in, and the design will have impact on how your organization work in this particular case. All right. So yeah, but that's a pretty good observation there. But notation wise, your textbook using the color coding to make it more clear. All right. So great. Let's move on. And so we are looking at a few more examples about ID dependent, and your slide or textbook talked about the different variation. Like in this particular case, a model and a vehicle, they can have an ID dependent or non-ID dependent. And this difference between A and B is depending again on your business situation and your design. Right? And during the implementation, which we will talk about in next chapter, that the significance is ID dependence or ID dependence model will have a key that insert into the weak entity. So on the left hand side or part A of the design, you see that the vehicle has a key called a manufacturer model, right? But on the other hand, that the vehicle has only a primary key called the vehicle identification number or VIN number. Right? So that's the difference. And both of them are valid design. Again, that we are facing a situation that using the ER model, we are creating design. We are not trying to create correct design. We are trying to compare and create the most fitable design for the business operation or uh, situation we try to manage data for. Right? So that's the thing. So which one is better, left or right? It really depends. If you are talking about a government, and it's probably better using the right hand model because they want to create a universal sort of like a surrogate key so they can search like personal IDs or citizen IDs type of concept. On the other hand, if you are a dealership and something that it's probably easier to manage vehicle. Or an alternative design is what you can have both. You can have both the VIN and all these different manufacturer information as well. Right? So that's the thing, and that also related to leads to the discussion of which data field or data attribute is required or not. Whenever we have ID dependent, when we say this ID dependent or ID weak entity, you make this particular attribute required. So when you enter the data row in there, you need to enter the manufacturer model and you need to enter the manufacturing sequence number. Right, so that's required. Required seems to be very good for data quality because every time you have a required field that you are forced to enter certain information. Now, this is required or not required is commonly seen by end user. So when you go to a particular website and try to create, say, a new user account. So during the process of creating a new user account, you have to enter all these fields: your name, your phone number, your email, your street address, and so on and so forth. And some of the fields that the application will ask you to enter, they probably put a red mark or asterisk to represent, oh, this is a required field. So if you do not put required field, you cannot move forward. You cannot submit the form. Some fields are optional. So the phone number may be optional. So you can choose to enter phone number or not. And the decision on uh, which one is required, which one is optional. It's fall upon the person designer database, and the designer need to talk to the stakeholder and the business owner, the company to figure out, which one is which, what we are required. And it become a very more and more significant in today's environment because now it relates to the data privacy issue that we are encountering. Who owns your data? Who has the monopoly? And by the way, the just very significant and recent news is I think the U.S. Department of Commerce is investigating the monopoly of Facebook, Google's, and what's the other company, Amazon, on their customer data practice. So that becomes a significant issue. And lead back to the database design. These required fields, it's required or not, leads to the discussion of when we are drawing the ER diagram, because these are before you draw the data diagram that you have to specify. And sometimes we don't know during the stage of design, but when you are implemented into the real website or real mobile application, that it has some consequence to it, legal consequences, operation consequences, and some other consequences, right? All right. So some of the discussion about the weak and ID dependent concepts here. Weak is related to the conceptual concept. ID dependent is about how you use the key or the column to control their relationship. So there's some relationship here, and try to kind of read a little bit more a few times to get a sense of how they are relating to each other. And moving forward, and after we understand this weak and strong entity and all these entity relationship they're identifying or not, we are pretty much finish up the traditional ER diagram concept. That's it, right? Well, the rest of the slide we are looking at are coming from the discussion of extended ER diagram. So these are the modeling concept borrowing from object-oriented world and coming to the ER world, and they become more and more useful in terms of building structure among data. Entity relationship diagram is used to build domain model in our system development process, and the domain model requires structure of how you put data and operation or work together. And the structure is explained better if you have the extended ER diagram concept, including the first one called the subtype entity. Subtype entity in object-oriented is called the parent-child or inheritance type of relationship. And it has, in the ER model, has a special notation called the exclusive or inclusive relationship. This is not showing the object-oriented model, but it's showing the ER model. The notation looks something like this. It's a circle with a cross or not a cross or no cross. With the cross being that it's a discriminatory, and using our logic operation statement, this is mutually exclusive. So the subtype are mutually exclusive. So in the design on the left hand side, it's pretty much it's saying that if you are an undergraduate student in our school, you cannot be a graduate student. You are either undergraduate or graduate. So that's the meaning of exclusive, mutually exclusive. And the notation is using a cross. And this one we will not be using in our assignment, but it's good to understand. And there are, again, depending on your business operation and how you are designing your in this case, it will be a university, right? So the question, if you look at the left-hand side, is we design the domain into you are either undergraduate student or a graduate student. So the business question will be coming that if you are running a university, this particular university here, are you going to be allowing the student that register or sign up into two programs in your school and be able to work on you can be either called a graduate student, undergraduate student, right? So that will be the question, right? And this will not be a question when we are kind of discuss this conceptually, but it will become a question in reality. As a matter of fact, when I was a PhD student, you know that if you're in the PhD program, you're pretty much like a half faculty member. So we were like teaching and doing our research and writing our dissertation at the same time. So one of my classmates, he is a much older person. He retired from General Motors, and he was a classmate of mine. And so he liked to talk about his career in General Motors and that sort of thing. And he is particularly interested in industrial history. So he liked to study the 19th century and 20th century United States century, industry history. So during the process of pursuing a PhD in management or in MIS in that particular case, he actually registered as he actually pursued an undergraduate degree in history in our school. And because, as a PhD student, you got tuition waiver for your program. So if your university database is designed like the one on the left, and that will not that will, you will have difficulty of handling allow your graduate student to sign up for undergraduate degree. So that's a consequence of it. Right? So the question in here from the business design corresponding to the information system design is, will you allow a student to sign up both undergraduate and graduate program at the same time? Right? And of course, you can move a student from undergraduate after they graduate to a graduate degree, but can they sign up two programs at the same time? Right? If the answer is yes, they can, then this model is not good. It's bad, right? So on the other hand, the example on the right hand side is the student can join hiking club, sailing club, or both. So it's inclusive. It's not mutually exclusive relationship, right? So I think that's easy to understand. And also there are relationship about has or does not have, and that's I'll kind of a fly over there, and because that sometimes is the so-called Hazer relationship. Actually, let me go back to the slide a little bit, and you see this verb here says has. In the ER world, we call them Hazer relationship or has a something. That is a very ambiguous relationship that creates a lot of confusion. I'll kind of try to avoid it. But the other important relationship is called the ISA relationship, or so-called the IS-A relationship. Also, we call them ISA relationship. Right? ISA relationship is whenever you try to build a relationship and you use the verb is a something and try to see if you can build that relationship. If it's true, then you can build a very strong supertype and subtype relationship. And for example, um, child and parents. So you use the relationship between child and parents as is child is a parent or parent is a child. The answer is no. So the relationship between them will not be a strong super and parent and child relationship. But if you look at um, teacher or actually no student and student and people. So you read student is a person or a student and person, student and person. And so you can use the verb here. It says student is a person. Then the relationship between student and person will be is a. And in object-oriented world, we call them inheritance. So the student is inherit from the person. But from the study of ER diagram perspective, you have to identify the difference between is a compared to has a or is part of. Right. So that's the main difference. All right. A summary of all the relationship in extended Crowfoot notation is on this particular slide here. And there is one little, again, detail I want to kind of pick on as part of our lecture. Is you see that the figure 5.14, the first word there it says IE. IE stands for in information engineering. Information engineering. Little and it actually represent a paradigm. It represents a methodology of database design, database management. This particular methodology is called information engineering. Is actually referring to ER diagram or the Oracle world. And Oracle engineering engineers start to use this terminology more than any other people. So this is another reason that we try to use Crowdfoot. It become more like a standard because Oracle was and still is the leading vendor for the relational database. So we tend to follow the information. So it's not industrial engineering; it's in information engineering in here in this particular slide. Right. So now we will move the slide a little bit further. We are looking at something what we call pattern. So your textbook, starting from this particular slide or the portion all the way to the end of the chapter, try to describe you. Okay, there are a lot of patterns. Some of the patterns are very useful. Some of them are not very useful. So some of the simple one like this one to one, one to n, one to many, and these are very simple relationship and the pattern representation is to give you some example, and you look at this example and know how they are related to the real implementation. So this is an implementation of a one-to-one strong relationship, and you have a person using a locker, and every time that you go to the gym or the some sort of a sports club, then you go in there, everybody has only one and only one locker. That's the rule of that particular club. And in the database, if you go into the check-in counter of that particular club, they might have some database or data entry interface look like this one. The representation of the design is represented by two strong entity. Strong because each one of them can exist by themselves, and their relationship is non-identifying relationship in this particular design, and but they are one-to-one relationship in here. So the entities, both entities are strong. Relationship is non-identifiable, and they have one-to-one strong relationship. One-to-many strong relationship, both entities are strong and they are not identifiable. Then you have a uniform and member, right? So not something special, and that to say about this. Many to many, this kind of worth a while to talk about the several times, and actually I mentioned this in previous lecture already. Many to many relationship exists in almost all, actually 95 to 99% of the real world situation. So every time you see a real world entity concept, you want to represent them in the database. It's almost always true many to many, regardless that you see some of the typical example we use one to many, but most of the time we have many to many in a real world situation. Right? So this is a typical many to many. We identify two things, company, parts, and there are many to many represented in this way, not something very special. And the next pattern is called also a small pattern called multi-value attribute pattern or archetype instance pattern. Let's take a look at what they look like. So this is a multi-value pattern. When we are discussing normalization theory, and these are called the multi-value dependency example. So you see that the record, the part number has multiple company name and multiple city, multiple countries. So the company vendor offer these parts. There are multiple vendor offer the same parts, and that's called a multi-value association pattern. And represent in, this is not the one we see previously. And this one is called association pattern. And when you have two entity that represent by many to many, so company and part in this case will be a many to many relationship. We represent them in a two one to many. This is a very typical implementation pattern that we use in database. Many to many become two to many relationship. And once you build a two to many relationship, you always has an ID dependent relationship. So the line are always solid. You see that the lines are solid, and the quotation, this intersection, the special name for this quotation is called the intersection table, or in this case, intersection entity is always ID identifying, and the quotation is always weak. You cannot create quotation unless you have part number and company name. That's what it implies. So this is another very commonly see pattern. Now this pattern need to be remembered because this is the pattern you will be using in your assignment. It's called the ternary relationship pattern, association pattern, and typical ternary relationship will be a project assignment pattern. So we have a project you have to assign to a client, and an architect or a consultant need to be assigned to this particular case. This happens over and over again, and more in today's organization because most of the organization today is operate in a teamwork project-based format. So you'll be creating a team working on a project, and the project is finished, the team will be dissolved, you'll be assigned to another project, even though you are working for a particular department. Then you. But of course, in a more traditional bureaucracy organization like university we are in here is less likely. But if you're going to work for a more modern organization, it's very likely you will encounter a more dynamic team assignment project-based type of organization structure. So this is a typical project organization. So just as a hint for your ER diagram assignment, you start with this basic pattern. By the way, what is a pattern? Right, think about that particular question. Pattern is a solution. Pattern is an existing design. Right, so if you are doing craft, right, a lot of lady friends like to do craft, do and they can go out by patterns, and the pattern can be used to create design very quickly. So pattern is actually an existing design. So this is an existing design based on experience from the past. We see there are a lot of repeating problem we try to solve in information system. Most of the time that if you want to build a data model or information system, it's likely somebody out there already built it. So why reinventing the wheel? Just use whatever people has done very well. That's the ideal pattern. So the difference between a senior, more experienced database designer compared to a less experienced is actually you encounter more pattern. So we will stop the recording, this second recording here, and we'll continue to talk about pattern in the next recording.